So for this is an assignment I shamelessly stole from someone else. Oh, I have to clone my screen. So as I was saying, this is something I shamelessly stole from another professor. Too bright?
No, I just can't see.
Oh.
I'm with my glasses.
Okay. So yeah. So it's a group assignment. So it is 4 parts. The first part is reviewing what you've already done. The second part is practice with lists. So the first part is reviewing like modular arithmetic and the dividing arithmetic we've done, right? Okay. So first part is manipulating numbers. The second part is manipulating lists. The third part of this is file reading, and the fourth part is doing some actual what you might consider science. Okay. And I'll open up a discussion thread as well for this assignment, because that's what the assignment said I'd do, even though it's really small and we don't necessarily need to do that here. So so we've got like a whole bunch of mathematics that exists in the world. Some of them are pretty obvious. Some of them are aesthetically pleasing, like the golden ratio. But this one is basically about hidden connections between numbers and weird stuff that happens with numbers when we look at them. So this assignment goes over what the number of social media posts each day, the population of every town in the United States and every town in Japan, or if I took any town somewhere else, the address of every faculty member of Temple, and the size of the tallest 100 buildings in the world all have in common. So we're going to be looking at what? The commas? Not precisely. We're looking, so with addresses, what we're talking about is like, so what we're going to look at is like the number of social media posts. How big are those towns? The address of every faculty member. So what are the numerical portion of that, of their numbers? And the tallest 100 the size of the tallest 100 buildings. So the end goal of this program, so I'm going to tell you what we're aiming to do. The end goal of this program is to write a program that determines the distribution of initial digits in a set. When I say initial digits, right, you might have the digits like 2, 1, 5, 1,376, 12, and 59. The initial digits in this set are 2, 1, 1, 5. They're the first digits, right? That makes sense to everybody, the first digits? The initial digits 2, 1, 1, 5. And so our data set would say we have 2 1s and 1 2 and 1 5, right? In this set of data. Okay? So we read in a number n and a list of numbers and output the nth of 10 values, the frequency of which 0 through 9 appears as the nth digit. So for the most part, we're just going to use it to examine the first digit. But we're also going to use it to examine the last digit, because both the first digit and the last digit of a bunch of numbers are used for fraud. The last digit especially. So a common thing is that when you're cooking the books, right, as an account, if you're like a fraudulent accountant, is that you'll manipulate, you'll put in whatever numbers, and then you'll manipulate the number at the end to make it seem like a random transaction. So maybe you'll add a 7, right, because 7 looks like it's a fairly random number. Or you'll put in a 2. You'll almost never put in a 5 or a 0 because those don't look random to a human. 5 and 0 look nice and like 5 is half of 10 and 10 is nice and a whole number. So those things look, so you don't end up, if you're manipulating stuff, you veer away from 5s and 0s a lot when you're modifying the data. And what ends up happening is that since those last pieces of data are very insignificant, really everything should have an even distribution, right? You should have as many 0s as there are 5s as there are 7s when you're talking about a large number of financial transactions. So this is one way that fraud is often detected, is that people who aren't mathematicians don't realize that numbers at the end are pretty much evenly distributed. Similarly, numbers at the beginning of numbers, the digits at the beginning of numbers, have their own distribution law, but it is not evenly distributed. Okay, that's the key here. So we're going to find that. Throughout the problem, we're going to assume that the numbers we're using are non-negative. Okay, so you don't worry about negative numbers. We're just going to deal with non-negative numbers. And so I break this down into multiple parts. So the first thing is that we're going to start with is like something we've done before, a count digits function, right? So in other words, how many digits does this number have, right? And the important thing is that you write all these functions in the same file. This is very important. You put all these things in the same file. So write this function, do it in the same file. Okay, nth digit back. Write a function called nth digit back that takes two ints, n and number. It finds the nth lowest order digit in num. In other words, nth digit back returns the nth digit from the right. So example, if you say 0, it gives you 3. If it gives you 1, well, it's 1 from the back, so it gives you 2. 2, if you ask for the second digit from the right, nth digit back, it'll give you the second digit from the right, so it gives you 1. If I give 3, it's going to go off the end, so it gives me 0. That makes sense to everybody? So you can use division, again, using division and modular arithmetic, not necessarily in that order, will actually really help here. Nth digit back, 3 over here will give me 0, 1, 2, 3. It will give me 8. Okay? Then we'll use that to write nth digit. You can call nth digit and count digits in this function and basically do, and this is actually a single line. But here it's the reverse. 0 will give you the 1, 1 will give you the 2, 2 will give you the 3 there, right? It gives you the nth digit from the left. All right, so 3 in this case, 0, 1, 2, 3. And yes, some of you are thinking, let's turn this into a string and just do the indices. But again, you can do it more efficiently by calling the numbers. So that's just simply review of the number portions that I know you guys hate modular arithmetic, but it's actually good exercise there. So now the second part is doing lists. So we're going to do something. I need to change the wording over here. So this is just from Java. This means an array, which is a list essentially of numbers. So write a function called an update tally, which calls nth digit. Right? It will use nth digit. So all of the methods we're writing use all of the methods that the previous method that you wrote. Right? So each part builds on the last part. Does that make sense? So I've taken the problem and broken it down for you into like do this, then do this, then do this, and then you have a working program. Right? So we assume that tally is a list of is a integer that has 10 numbers in it. So, right, an int list. The tally contains the tally of nth digits seen so far. It updates tally to reflect it. So here, for instance, if I pass in 1072, and here's the digits I've seen so far. So I've seen 0 zeros, 0 ones, 1 2, 2 threes, 0 4s, 0 5s. I've seen 3 7s so far, and I've seen 3 6s, 0 7s. So update tally. This will get the second from the left, so we'll get the 7, and so it updates the 7's place by 1. That makes sense? I've seen 0 7s, and after this function, I've seen 1 7. This is the more common usage, getting the leftmost digit, which is the 2 over here. The 0s, 1s, 2s, 3s, 4s. How many 2s have I seen so far? Well, after this function call, I go from 1 2 to 2 2s. Make sense? Since we're modifying tally, update tally will be a void function, which returns nothing, right? It's not going to return anything. Void function, that's just something from, again, Java. Okay, so now what we can do is we can call something called the nth digit tally, which will take in a bunch of arguments, the number that we're interested in, and an array of numbers, which is a list of numbers. So, for instance, this is a sample test case, just to give you an idea. Here's the enrollments for the Research Triangle colleges and universities in fall 2007. Anybody know what the Research Triangle is? So it's a area in North Carolina of a bunch of universities that basically form a small triangle where there's a bunch of colleges and a large amount of research goes on there. Hence why it's called the Research Triangle. So assume that the variable enrollments contains just these numbers, okay? Just these numbers. So the nth digit tally, 0 enrollments, would say, okay, of these things, let's see, none of these started with 0. 3 of these started with 1. That making sense? 3 of them started with 1. 4 of them started with 2. 1 started with a 3. That making sense to everybody? How this? So we store all these in a list. Got it? All these numbers are in a list. Nth digit tally processes this list and says, I want to look for the frontmost digit in all these. Okay? And now what we'll do is that, and then your last one is to write a function that reads a white space separated files from integers from a file and returns a list of numbers that are suitable to be called into the function. So here is where it gets interesting. You basically will read in basically a file that contains this and returns a list and pass it to the other function. And what you'll do is that basically what this will do is that you just simply let the user enter in what number they want to, what the leading digit they want to look at, which digit they want to look at, and what file they want to look at, and then it will print out the counts, right? So there were 0 zeros, there were 3 1s, 4 2s, 1 3 for the leading digits in our example. Okay, and the last part is we're going to use it to make observations. So once we have this working, we can pretty much analyze any file that's just a list of numbers, right? So what you want to do is then you as a group, you want to look at some data source that nobody else has looked at, that nobody else on the course has chosen yet. Normally you have to post on the forum to stake a claim, but honestly with 4 groups here, or 3 groups if I make one of you a trio, that's a pretty small section, right? You can do something like the measurements of the flow rates of all the major rivers in British Columbia, measurements of the 10,000 randomly chosen of the height of 10,000 chosen Vancouver residents, measurements of the hits per day of University of Berkeley, California's computer science website over 3 years, the measurement of length of characters in each article in Wikipedia. So long as there's 250 numbers, this should work as to what I'm intending to do. Right, your data set should work. So here, the idea is that you're going to go out on the internet and find some kind of data set. I will have some default data sets posted in just a second. Okay, so again, this looks like a lot, but I've broken it down into very small chunks. Each of these small subsections is a small function that takes no more than 5 lines, essentially. All right, so do people want to work in the same groups or different groups? I feel like you guys should work in different groups because variety is the spice of life. So, okay. And do we want to have a trio, or does somebody want to work with me and be subjected to my torture? You want to?
Yeah.
Okay. Okay, no problem. Hey. So let's go. So classes. So we've got 20 minutes left. We'll work on this right now, and then when we get back to class on Thursday, we'll work on this and the other, and then the next, and then the hurricane tracker. Okay. All right. So go ahead and form up into new groups.